I'm Caroline.
I'm Claire.
I'm Paige.
And this is our physics video.
Mechanical energy is the sum of kinetic energy and potential energy. Because of the conservation of mechanical energy, the initial kinetic energy plus initial potential energy is equal to the final kinetic energy plus the final potential energy. For example, a basketball with a mass of 1.75 kilograms begins at 3.83 meters above the ground with an initial velocity of 0 meters per second. The ball is then dropped to 2 meters above the ground. After using the equation for the conservation of mechanical energy, the final velocity turns out to be 5.98 meters per second. When the ball is at rest at 3.83 meters above the ground, it has pure potential energy. As the height decreases and velocity increases, kinetic energy increases, but the total sum of mechanical energy always remains the same.
In physics news tonight, mechanical energy is the ability to do work. It is the sum of potential energy and kinetic energy. Because of conservation of mechanical energy, the sum of potential energy and kinetic energy will always remain the same. Potential energy equals mass times acceleration due to gravity times height. Kinetic energy equals 1/2 times mass times velocity squared. Mechanical energy initial will always equal mechanical energy final. This is an example of mechanical energy.
When the ball is at its highest point with no velocity, it only has potential energy. As the ball drops, it loses potential energy and gains kinetic energy, but the total amount of energy stays the same throughout the fall because of conservation of mechanical energy. When the ball is halfway to the ground from the original height, the potential energy and kinetic energy are equal to each other. Momentum is the product of mass and velocity, and the symbol for momentum is p. Impulse is change in momentum, and it is the product of force and time. Greater time equals less force, and greater force equals less time. A baseball of 0.75 kilograms travels at a velocity of 21 meters per second to the right until it hits a net for 0.6 seconds until it comes to rest. Find the force of the ball on the net. After plugging in all of the variables into the equation and solving for the force, the result is 26.3 newtons to the left because the net is stopping the ball, which is going in the opposite direction. Because the change in time is small, the force is greater than it would be if the change in time was larger.
Now with Paige on momentum.
Momentum is the product of mass and velocity. The symbol for momentum is p. Any object that moves has momentum. Impulse is the product of force and change in time. When there is a greater time, there is less force. When there is a greater force, there is less time.
This is an example of momentum.
Momentum is the product of mass and velocity. Because Claire has a mass and is covering a distance over time, so she has velocity. And the equation for momentum is mass times velocity.
This is an example of impulse.
Impulse is the product of force acting on an object over time. As Claire comes to rest quickly, she applies a large amount of force because the amount of time she takes to stop is short.
This is another example of impulse.
When she takes a longer time to stop, Claire uses less force, but more time to get the same impulse.
Elastic energy is when two objects collide but don't stick. Because of the conservation of momentum, momentum before the crash is equal to the momentum after the crash. For example, a bowling ball with a mass of 8 kilograms rolls down the lane at 12 meters per second until it hits a bowling pin with a mass of 0.6 kilograms that was at rest and now flies backwards at 6 meters per second. What is the final velocity of the bowling ball? After plugging in the variables and solving for the first final velocity, the result is 11.6 meters per second to the right because the bowling pin moves in the same direction as the bowling ball. Because of the conservation of momentum, the energy before the collision equals the momentum after the collision.
Now on elastic collisions. Elastic collisions happen when two objects do not stick together, but the energy before the collision equals the energy after the collision, because of conservation of energy. If sound is produced, then the collision is neither elastic nor inelastic, because the sum of the kinetic energy is connected into sound energy, so the energy before and after the collision is not equal. For example, a bowling ball with a mass of 8 kilograms rolls down the lane at 12 meters per second until it hits a bowling pin with a mass of 0.6 kilograms. That was at rest, flying backwards at 6 meters per second. The final velocity of the bowling ball is 11.55 meters per second. So the momentum before the collision equals the momentum after the collision.
As the player hits the puck, he exerts a force on it and causes it to cross the ice. It ends up hitting the wall and bouncing back. This is an example of an elastic collision.
Inelastic collisions occur when two objects collide and stick together, forming one mass with one final velocity. Because of conservation of momentum, the momentum before and after the collision are equal. A football player with a mass of 74 kilograms runs at 11 meters per second to the right, chasing another player of 136 kilograms carrying a football moving at 6 meters per second to the right. The first player tackles the second player. What is their final velocity? After plugging in the variables, the final velocity turns out to be 7.76 meters per second to the right, because both players are running in that direction. They have one final velocity because they are now one mass.
Inelastic collisions occur when two objects collide and stick together. For example, one football player tackling another. Because of conservation of energy, the energy before the collision equals the amount of energy after the collision. Mass 1 and mass 2 are different, but after the collision they are one mass with one final velocity that is equal to the energy before the collision.
This is an example of inelastic collisions. Inelastic collisions occur when two objects smash into each other and stay together as one newly formed mass. Because of conservation of momentum, the momentum before the collision is equal to the momentum after the collision. When the lacrosse ball and stick collide, they become one mass with one final velocity.